Hello students, here we will discuss some problems regarding the circuits. So up to now we discussed about some of the methods to solve the circuit. Here we will take some examples. Here in the network is a 20 volt source is there and two resistors is connected, and he is asking to find out the I1 and I2. Two currents flowing in the two branches he is asking to find out. We will have different number of methods, we will discuss each and every method. So the normal method, the first normal method, look at here. Here a source, two resistors are connected, he is asking to find out this current and this current, but we don't know how much of current flowing from the source. In order to find out the source current, this current, you have to simplify the resistive net current, first thing. So that's why once again you have to write is a 20 volt source and it is connected to 10 ohms resistor, again 10 ohms resistor, right? And in order to find out, but our intention is to find out the current from this source. Just I am assuming Is. You can take anything, I1, I2, Ia, Ib, like that. So in order to find out this, just you simplify this network. Simplify the network means you have to simplify this resistive network. Here 10 ohms both are connected in parallel. So in order to find out this equivalent resistor, R equivalent equal to R1, R2 both are in parallel. So formula is R1 into R2 by R1 plus R2. R1 plus R2. From this 10 and 10, 10 into 10 by 10 plus 10. If you solve this, the equivalent resistor, you will get the 5 ohms. So just write the 5 ohms at here. So simply this is a 20 volts and the replacing the network with a simple resistor 5 ohms. 5 ohms. Now the source current is, in order to find out the current, apply simply KVL by KVL. What is KVL? In a closed loop, total voltages will be 0. So here the voltage itself, this is the source, that's why it starts from here, that is minus 20. This is one thing. What about voltage across 5 ohms? This is, so current and resistance equal to 0. Resistance equal to 0. Simply voltage across 5 ohms means current flowing through the resistor is Is and resistance value is 5. Then you solve this, you will get Is equal to 20 by 5. So Is value equal to 4 amps. Is value equal to 4 amps simply. So this is the, you will get finally the 4 amps. So this is a 20 volt source and 10 ohms. This is 10 ohms. So here source current is there and I1 and I2. So now you have to find I1 and I2. Now you will apply a formula, the formula is current division rule. You can apply here current division rule. Current division rule. Simply you will get that. From this current division rule, like this, that is, some current is flowing through the two resistors are connected in parallel. Two resistors connected in parallel. This is one resistor and another resistors. Some current is flowing, we don't know the current, that current value I1 is flowing through the R1 and I2 is flowing through the R2. This is the current flowing. Then you can directly write the I1 formula and I2 formula. I1 formula is like this. I1 is formula, current division rule represents total current into opposite resistance by total resistance. So look at here, in order to find out the I1, so what is total current? This is the total current actually. What is total current? Total current means how total current entering into R1 and R2. What is total current? I into what is opposite resistance? For I1, R1 is the resistance. What is opposite resistance? R2. Just write R2, and total resistance means R1 plus R2. This is the formula. In order to find out the I2 also same formula. Total current into, for this, in order to find out the opposite resistance is R1 here and R1 here, the total resistance is R1 plus R2 here. R1 plus R2. So any network you can apply this formula. For any network you can apply this formula. This is important formula which will be very applicable in solving the electrical circuit. This is important formula, very applicable. So to find the current I1, whenever total current is given, when two are connected in parallel only. Otherwise it is not applicable. Parallel. Look at here, R1 is parallel and R2 is parallel. The total current entering is I1. So in order to find out the I1, the formula is total current into opposite resistance by total resistance R1 plus R2. So then formula is like this. So in order to find out I2, such same thing, total current into opposite resistance by R1 plus R2. R1 plus R2. Next. So from that you can apply this formula. So you know that the formula is simply here, the IS value we already get here 4 amps, then you will apply this. So in order to find the I1, what is total current? Source current is 4 amps here, 4 into what is opposite resistance for I1? 10. 10 by total resistance 10 ohms plus 10 ohms. 10 ohms plus 10 ohms. So by solving this you will get 1 by 2, that is 2 amps. For I2 also same thing. For I2 the total current entering 4 amps. For I2 what is opposite resistance? 10 ohms by the total resistance. 4 1 by 2 again same. So the current I1 is 2 amps, the current I2 is 2 amps. Just observe here why the two currents are same. Look at here. Here a source is there. This source will supply the power to this resistor and this resistor. If you observe here, these two resistance are same. These two resistance are same means these two resistance are absorb same electrical power. So in order to observe the same electrical power, already same voltage. So this is a parallel branch. So this 20 volts is applied to 10 ohms and 20 volts is applied to 10 ohms. Those are same magnitudes. So automatically it will take same current. Same current means the total current is 4 amps. So automatically they will divide equally. Why divide equals? Because the resistances are same. That's why you will get I1 value 2 amps and I2 value 2 amps. Understand? This is the procedure to solve the normal procedure to solve a simple circuit, a simple parallel branch circuit. Understand? So in this current division rule is important. It is very applicable in all the circuits. Okay. This is the one method. We will look into the another method. Now we will discuss method 2 to solve the above circuit. Already we will discuss method 1. Okay. In this method 2, I will follow the nodal analysis. Already we discussed about the nodal analysis theory and example problems related to nodal analysis. Actually, this is important method and simple method. By using this method, you will save the time. Within 3 or 4 steps, the problem will be completed. So look at here. So first, in order to apply the nodal analysis, first you observe how many nodes are available in the circuit. So this is the circuit, this is 20 volts and this is the 10 ohms, and the second resistor is again 10 ohms. So in order to apply the nodal analysis, first you have to observe how many nodes are available. We have only one node. Just keep it, the node voltage is V. Assume the node voltage is V. And but our requirement is to find out the I1 value and the I2 value. I1 value and the I2 value. So before applying the nodal analysis, just observe the diagram. What is V value? What is V value? How we will get the V value? So generally, wherever the return path is there, we have the 0 volts here. Ground. This is the ground. Ground is always 0 volts. So if you observe here, V value is nothing but the voltage across this branch and voltage across 10 ohms resistor and voltage across 10 ohms resistor is same. So if you observe voltage across this branch, look at here, voltage across this branch means this is the 20 volts. Actually directly by observing the node, we will get the voltage of this branch is 20 volts. Understand? That means voltage across 10, voltage across 10 all are same. So just write what is V value? V value is the 20 volts. Already we get the V value. So just observe, simple tricks is there. Don't think too much, just simple tricks. Next, again what is V value? V is nothing but the voltage across this 10 ohms resistor. But what is our requirement? Current is our requirement. So in order to get the current I1, how we will get? So in order to guess, if you take current I1, what is current I1? The voltage of the element by resistance of the element by Ohm's law. By Ohm's law. So by Ohm's law, current is voltage by resistance. Voltage means potential difference between the 2 points. The first point is V, the second point is 0, the element resistance is 10 ohms. So you can write like this, V minus 0 by 10 ohms. But we know that what is V value? V 20 by 0 by 10 ohms. So 20 by 10 is simply 2 amps. Simply 2 amps. Understand? Why? The parallel branch in every in a circuit we have number of parallel branches. Parallel branch means one point is connected to this, another point is connected to this. One point is connected to this, another point is positive is connected here, negative is connected here, like that. Next, for I2 also, I2 one point potential is V, another point is potential is 0. Potential is nothing but voltage simply. So that's why I can write V, 1 point voltage is V, another point voltage is 0 by that resistance. The resistance is 10. Same procedure. This is the 20 by 10. We will get 2 amps. So by the 3 steps you solved the problem. By the 3 steps directly you solved the problem. That's why nodal analysis is very simple method. But in order to proceed the nodal analysis, just you follow the rules. Observe the number of nodes and what is the voltage of the node. In this problem directly we will get, because directly V is connected here. Every problem it is not possible. Wherever not possible you have to find out. So this is the method 2, nodal analysis. You will go for the method 3. That method 3 is loop analysis. Already you have some idea regarding the loop analysis, because we will get same answers. So in your notes you have to go the loop analysis. So they will get I1 and I2 both are same. So otherwise you can contact me. Definitely it will come same, right? So now you observe method 3 if you by finding the loop analysis, and method 2 already applying the nodal analysis. Method 1 is simply circuit simplification method, the first method, circuit simplification method. By that means circuit simplification means by first by reducing the resistors and finding the source current. Again we are applying the current division rule. So by all these methods, my preference method is nodal analysis, because within 3 steps we will complete the problem. So whichever the method is you felt easy, you will follow that method, but you have to save the time as well as you have to complete in a proper manner. Understand? So this is about the 3 methods to solve this. So all of you find out the loop analysis and compare it. Okay? This is the methods. Understand? Okay. The second problem. Now the second problem. Second problem is given 20 volt source and 2 10 ohms resistors are connected in series, and he is asking to find out the V1 and V2. What is V1? V1 is voltage across first 10 ohms resistor. V2 is voltage across first 10 ohms resistor. So wherever the V1, V2 are there, these are directly voltages simply. Wherever current I1, wherever V1, V2, V3 there, voltages V1 and V2 like that. Simply directly he mentioned to find the voltages. If you mention the currents I1, I2 like that, I mentioned, he is asking to find out the currents because these are the symbols. So we will find out by the normal method. In order to find out the, simply observe here, in order to find out the voltage here, what is our requirement? We required current passing through this, and already we have the resistor. We will find out. Same here also. So what is the condition? To find out the current in the circuit. So in order to find out the current in the circuit, first again redraw this circuit. If you redraw this circuit, this is 20 volt source and we have 10 ohms resistor, and then we have the again 10 ohms resistor. This is the current actually. So generally simply apply the one current is there, that is I. If you apply the KVL by applying the KVL. So what is KVL? So this is source always having minus starting, the elements having plus. That's why the voltage across this point, the voltage across this point, the voltage across this point in a loop will be 0. That's why the voltage across source is the minus 20 plus the voltage across this point is I into 10 ohms plus the voltage across this point I into 10 ohms. So if we solve this, this is the minus 20 plus 20I equals to 0. What is the I value? I value equal 20 by 20, that is 1 ampere. So the total current from this circuit is 1 ampere. Now you will find out simply voltage across this. V1 equal to the current flowing through I into resistor. In order to find out the voltage V1, current flowing through that and the 10 ohms resistor. Current flowing is already we find out the 1 ampere and 10. What is the voltage? 10 volts. Understand? Next same also, same thing, V2 is also I into 10, that is directly 10 ohms, simply applying KVL, directly we will find out. So if you observe very clearly, that is here 20 volts source and one resistor drop is 10 ohms, plus minus I am writing. Here the another resistor drop is 10 ohms. Circuit is closed. If you apply the KVL, it is satisfied simply. 20 volts is supplying to 10 volts and 10 volts. The reason is here the minus 20, because start from the minus. Always start from here, plus 10 will satisfy the 0. That's why we are applying the KVL here. This is the one method. by applying KVL method. Directly we can find out, we have the one method is there, one formula is there, that formula is voltage division rule. Voltage division rule. Voltage division rule is applicable for the series circuit, whenever two resistors are connected in series, this circuit. So this is V, this is R1, the voltage across this is, for example, V1, the same circuit, and we have R2, the voltage across this circuit is V2. Then the voltage across, in order to find out the voltage across one resistor V1, the V1 we can find out any resistor V1 is like this. Total voltage into source voltage or total voltage into voltage across resistor by total resistance. Voltage across, not voltage across actually, resistance of the resistance by total resistance. Total resistance. That means look at here. That means look at here, V1 equal to, the total voltage is simply, this is the source voltage. The total voltage means this voltage is supplying voltage to resistor 1, voltage to resistor 2. Total voltage into V, that resistance is R1 by R1 plus R2. R1 plus R2. This is the formula. This is the formula. Same as, in order to find out the voltage across V2, that is also simple. The total voltage into that resistance is R2 by total resistance R1 plus R2. R1 plus R2. This is a shortcut method. It will be very useful. It will be very useful. Now we will apply this formula to this circuit. Now we will observe, we will get right answer or wrong answer. So from that circuit actually, so in order to find out the voltage across this 10 ohms resistor, so I can write, for example, V1, take it as V1. V1 means total voltage is, supply voltage is 20 volts by 20 volts into that resistance value is 10 ohms by total resistance 10 plus 10. So simply you will get 10 by 20, 2 times 2, 10 times, that is 10 ohms. Observe here, we will get V1 value is simply 10 ohms, right? Next, V2 also, V2 means voltage across this resistance. So what is the formula? Total voltage, total source voltage is 20 volts into that resistance value is 10, total resistance 10 plus 10, 10 plus 10. If you solve with this, you will get 10 ohms. Look at here, within 2 steps we will find out. Within 2 steps we will find out. It is applicable for only series circuit. We already discussed about the current division rule. Current division rule is applicable for the parallel, because voltage is divided in series circuit. Voltage is constant in parallel circuit, same. But current is divided in parallel circuit, current is constant in series circuit. That's why divided. Understand? This is the 2 methods to solve this type of methods. This is a normal method, applying KVL method, finding the current and finding the voltage, normal method. But this is the direct method. So these are the some problems related to this KCL, KVL and voltage division rule and current division rule. Okay, thank you.